Hello class, today we'll be talking about 11.7 involving and conditional probabilities. So some objectives we're going to be looking at, we're going to find the probability of one event and a second event occurring, and we're going to compute the conditional probabilities. So independent events are two events are independent if the occurrence of either of them have no effect on the probability of the other. And the probabilities of the independent events, if A and B are independent events, then the probability of A and B is equal to the probability of A times the probability of B. So now you're dealing with multiplication. We're dealing with adding before, now we're dealing with multiplication. So a U.S. roulette wheel has 38 numbered slots, 1 through 36, and then 0 and 00. 18 are black, 18 are red, and 2 are green. The ball can land on any slot with equal probability. What is the probability of red occurring on 2 consecutive plays? All right, let's look at this. Let's look at it. So if we think about this, the probability of getting red, so the probability of getting red and red is equal to the probability of getting a red and the probability of getting a red, right? Which that's 18 out of 38 times 18 out of 38. Because it's 18 red balls. 18 red slots. So it has 18 out of 38 chances of getting it. Therefore, now I can go ahead and reduce these to what? 9 over 19. So it's 9 over 19 times 9 over 19, and then this equals 81 over 361. Now, putting it in decimal form, it's roughly about 0.224. So this would be your probability if you need it in decimal form. This would be it if you need it in fractional form. All right, because we know we got what? 18 18 spots, and we have what? These right here. And it's out of 38. All right, let's look at the next question. It says, if 2 or more events are independent, we can find the probability they all occur by multiplying their probabilities. Okay, it says the probability of having a baby girl is 1/2. Find the probability of having 9 girls in a row. Now, if we know the probability of having a baby girl is 1/2, then now I'm not going to write out 1/2 9 times. So the probability of having a girl, let me say baby girl, all right, is equal to 1/2 raised to the what? 9th. Which that equals what? 1 over 512. So you got a 1 over 512 chance of having all girls if you have 9 children. So just make sure when you're doing these problems, you understand what the question is asking. Make sure you also underline stuff that are important. All right? So let's look at this. It says if the probability of that South Florida will be hit by a hurricane is in any single year is in any single year is 5/19. What is the probability of South Florida will be hit by a hurricane in 3 consecutive years? Now, the same case. Now, you can rewrite this. Since it's only 3, I'll write it out. So, it's the probability of a hurricane and another hurricane and another hurricane, which is what? 5/12, 5/19 times 5/19 times 5/19. Or you could have did 5/19 raised to the 3 if you really wanted to. All right? That equals what? 125 over 6,859. Now, and that's roughly, if we put that in decimal form, 0.018. That's your fractional, that's your decimal. Now, only put it in decimal form when it asks you to. It's going to tell you to round to the nearest whatever. So keep that in mind. So let's look. Now, what is the probability that what? It will not. So now it's asking the probability that will not be hit by a hurricane in the next 10 years. So now we know what the probability that it will hit, right, which is 5/19. Now, the probability of it not hitting, so probability of not hitting, of not E, is equal to 1 minus the 5/19, which is equal to what? 14/19. Now, if we look at the probability of hitting in 10 years, that'll be what? So the probability of hurricane next 10 years. Would just be your what? 14/19 raised to the 10th. Which, if we put that in the calculator, all right, and we're just going to put it in decimal form, it'll be 0.047. Now, because it said 10 years. So it's going to be the same thing every year. That's the probability of each year is 5/19. So we're going to do what? Subtract that from 1. That's going to give me 14/19. Then we have to raise it to the 10th power. So let's look at this. It says, and probabilities with dependent events. So now they're what? Dependent, not independent. So the probability of dependent events, if A and B are dependent events, then the probability of A and B is equal to the probability of A times the probability of B given that A has occurred. So A has to occur for B to what? To be used. All right? So let's look at these. Now, it says, and this is a long question, yes. It says you have won a trip to Madrid, and you can take 2 people with you. All expenses paid. Bad news. 10 of your cousins have appeared out of nowhere and are begging you to take them. You write each cousin's name down on a card. You place the card in a hat and you select one name. Then you select a second name without replacing the first card because you don't want to pick the same person twice, right? Okay. It says if 3 of your 10 cousins speak Spanish, find the probability of selecting a Spanish-speaking cousin. So we're gonna have the probability of speak Spanish times the probability of speaking Spanish, given that the first cousin spoke Spanish. All right. So let's look at this. Now, we're picking how many? 3 out of 10. All right, 3 out of 10 speaks what? Spanish. So that's our A. That's our probability of A. Now the probability of A given B will be what? How many people we should have speak Spanish? 2 more. And how many people we have left? 9. So when we multiply those 2 together, we get what? 6 over 90. And that reduces to 1 over 15. Now I'm gonna put it in, I'm gonna give a rough estimate, and that would be 0.067. Now this is your decimal answer and this is your fractional answer. Now, if you understand what I'm saying, this is how, now remember what I was just saying. You have 3 cousins that do what? Speak Spanish. And it's out of 10 of the cousins. Now, since you already taken one out, you're left with what? 2 Spanish-speaking people out of the 9 that are left. All right? That's why you're using those. So that's why it says the probability of A and B is the probability is the probability of A times the probability of A given of the probability of B given that A has occurred. So if we already got a Spanish-speaking cousin, that means we have what? 2 left. All right, out of the 9 that's left because we didn't replace. All righty. Let's look at this one. 3 people are randomly selected, one person at a time from 5 freshmen, 2 sophomores, and 4 juniors. It says find the probability that the first 2 selected are freshmen and the third is a junior. All righty. So the first thing we need to do is find the probability of getting a freshman. So it'll be what? So if we were to look at this, we have the probability of getting a freshman times the probability of getting a freshman given that a freshman was chosen or given that a freshman was selected already. All right, then that'll be times the probability of getting a junior. Now, I just put the probability of getting a junior, but that's the probability of getting the junior given that a freshman was selected for the first and the second selected. All right? So these probabilities, now we got how many? We have 5 out of how many people? 11, right? You got 5 plus 2 plus 4. That's 11. And it's times, now, since I already got a freshman, it's 4 freshmen left. And it's out of what? 10 people left. Then, if we look at juniors, we have what? 4 juniors. Since I already selected another freshman, I'm missing another person, so it'll be out of 9. Now, when I multiply all these together, all right, I'm going to wind up getting what? 8 over 99. So you just put in the calculator, you're just multiplying all these different factors together. Now, a lot of this stuff reduces. But when you put in the calculator, you just get 8 over 99. It automatically reduces for you. So basically, it was the probability of getting a freshman times the probability of getting a freshman, given that the first was a freshman. Then it was the probability of getting junior, given that the probability that given that we got a freshman for the first and for the second selection. All right. So make sure if you don't understand something, you make sure you hit me up through Microsoft Teams. Now, conditional probabilities. All right. The probability of event B, assuming the event A has occurred, is called the conditional probability of B given A. The probability is denoted by the probability of B given A. So this is the way you can write this. All right, let's look at this real quick. Let's look at this one. So, it says a letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome of a letter, given that the outcome is a letter that precedes H. So let's look at the sample of this. So the probability of value of getting the vowel, and then given that the letter precedes H. So our sample would be what? A, B, C, D, E, F, G, right? So that means everything that's before H. Now let's look. Let's get this probability going. So we know how many different vowels. How many different numbers do we have? Letters do we have? 1, 2, 3, 4, 5, 6, 7. So the number that's in my sample is 7. The number that's in the event, we got to count all the vowels. So if we go back, we have A, we have E, and that's all the vowels we got. So we have 2 in our event. Therefore, if we find the probability of this happening, we have what? 2 out of 7. Because it can either be A or what? E. Now, make sure if you got any questions about this, you send me a message through Microsoft Teams or you send me an email. So let's look at this. Now, this is assuming these numbers are representative of all U.S. women from the age of 40 to 50. Find the probability that the women in the age range has had a positive mammogram, given that she does not have breast cancer. All right. So let's actually work this out so I got more room. So positive mammogram, and given that she does not have breast cancer. So we know that she does not have breast cancer. So we'll use the 6,944. Now, the thing is, we need to do what? Find the overall. Right? So, no breast cancer. We have what? We got the total number right here. All right? So we're going to do these two numbers. So we have what? We have 6,944. And we're going to put that over what? 99,200. And then we'll get what? 0.07. So this is one of the real world applications. And when we did it, we just used the chart that was given to us. Now, they could have said you could have added this one with that one, and then you still would have got that. But it was already given. So why have to go through all that? It gave you the total already for you. So you just had to pick out positive mammograms, and then it had to be in the section with what? No breast cancer. And then you had to put that number over the what? Total number. And you got 0.07. Now, if you have any questions about this, make sure you send me a message through Microsoft Teams or send me a message through email.